Phobos Monolith. You may remember news of a mysterious monolith that had been sitting in the Utah desert back for 4 years in 2020. But did you know that there are dozens, if not hundreds of monoliths scattered across the solar system, and one particular monolith, the Phobos Monolith, is 300 feet in height. The Phobos Monolith sits on the moon Phobos, which belongs to the rocky desert planet of Mars. But Phobos is not alone, as Mars also has a monolith to its name, appropriately titled the Mars Monolith. The Mars Monolith is a rectangular object that was identified on Mars's surface. Orbit imagery taken from the Mars Reconnaissance Orbiter at around 180 miles away shows that the Mars Monolith sits at the bottom of a cliff, which scientists believe it likely fell from. While Mars might have its own monolith, the monolith that belongs to the moon Phobos is significant due to its sheer size. According to scientists, the Phobos monolith is much larger than the monolith in Utah that sent the media in a spin. In fact, data suggests that the Phobos monolith is 279 feet in width and 300 feet in height. The Phobos monolith mystery is amplified by the fact that Phobos is completely barren. Whilst Mars has an atmosphere and a weather system, Phobos sits silently in space, with its solitary monolith pointing up towards the heavens. What's more is that Phobos is tiny compared to the grand scale of the universe, making the sight of something so massive atop of a small celestial body even more creepy. The effects of erosion are common for strange discoveries on other planets. Mars itself has been the subject of many strange discoveries, such as the Mars Face, the Mars Pyramid, and even the levitating spoon. These rock formations are usually a result of our perspective from Earth, as well as millions of years of rock degradation. While interesting to many, Phobos has yet to receive any significant research or space exploration. Optech and the Mars Institute have proposed that the site of the monolith be investigated. This mission is referred to as PRIME, fully known as Phobos Reconnaissance and International Mars Exploration. The proposed mission would see a lander touch down on the surface of the lonely moon to take samples of the moon's geology. Currently, the PRIME mission is not set to go ahead, and talks of funding are next to non-existent. However, famed second man on the moon Buzz Aldrin has previously supported the idea of a mission to Phobos, so there might be a chance in the future. In fact, when Aldrin discussed the idea of sending a mission to Phobos, he said, "When people find out about that, they are going to say, 'Who put that there? Who put that there?'" Did our DNA come from space rocks? The building blocks of our DNA have been discovered in space rocks, begging the question, did our DNA come from space rocks? It's possible that cosmic impacts brought the ingredients needed to create life on Earth. DNA is made of 4 vital ingredients: nucleobases named adenine, thymine, cytosine, and guanine. For years, scientists wondered if meteorites could have brought these ingredients to Earth. However, until now, only adenine and guanine had been detected. Nucleobases come in 2 forms, called purines and pyrimidines. For a long time, only purines were seen in meteorites, and pyrimidines seemed to be missing in action. The main difference between the two is that purines are made from a hexagonal molecule fused with a pentagonal one, while pyrimidines are smaller and are made from just the hexagonal molecule. Scientists have now been able to find all the purines and pyrimidines that are in DNA and RNA in the meteorites that arrived on Earth. According to the astrochemist who led the study, Yasuhiro Oba, the presence of the 5 primary nucleobases in meteorites may have a contribution to the emergence of genetic functions before the onset of life on the early Earth. The methods used in this study to detect the nucleobases demonstrate the incredible scientific advancements that have been made in recent years. Researchers used techniques that were originally designed for genetic and pharmaceutical research, that are able to detect nucleobases down to the range of parts per trillion. The techniques used were at least 10 to 100 times greater in sensitivity than previous techniques to detect pyrimidines in meteorites. The samples analysed in this study were from 3 carbon-rich meteorites, that had been previously suspected of having the capability to host chemical reactions that created nucleobases: Murchison, Murray, and Tagish Lake meteorites. Although it's still unknown why purines were much more abundant in the meteorites than pyrimidines, one clue could be that purines contain a pentagonal ring called imidazole, while pyrimidines do not. Whatever the reason for this discrepancy, one thing is for certain: this study could be a breakthrough in understanding how life formed on Earth. Large Hadron Collider revs up to unprecedented energy levels. When it comes to particle physics, discoveries are being made at such a rapid rate that even industry giants such as the Large Hadron Collider are having to up their game to stay up to speed with the ever-advancing knowledge. The Large Hadron Collider, which is the world's largest and most powerful particle collider, is ubiquitous within the physics world as the catalyst for the discovery of the Higgs boson, which confirmed the existence of a particle that was said to have caused the so-called Big Bang, that led to the formation of our entire universe. But it seems that this is no longer enough, and researchers have been preparing to ramp up the LHC to probe the inner workings of the building blocks of our universe at more powerful levels than ever before. The machine works by slamming proton particles together at unfathomable speeds to record the resulting collisions, and following a 3-year break to update its capabilities, it has restarted and is running at record-breaking speeds of 13.6 trillion electron volts, which it will continue non-stop for at least 4 years. During this time, it will send 2 beams of protons in opposite directions around a 27-kilometer ring at speeds approaching the speed of light. The proton beams themselves will be less than 1/7 of the diameter of a human hair, which will hopefully allow around 1.6 billion proton-proton collisions per second, according to Mike Lamont, the head of accelerators and technology for the European Organization for Nuclear Research. This is an incredible increase in collision rate of about 20 times, which Lamont described as a significant increase, paving the way for new discoveries. The collider, which is owned by the European Organization for Nuclear Research, lies buried 100 meters below the Swiss-French border, and the results of the collisions will be analyzed by scientists from organizations all over the world for insights into such mysterious principles as dark matter and dark energy. Additionally, this new increased energy rate will hopefully allow researchers to study the properties of the Higgs boson even further, as there are still many questions and potential discoveries regarding this groundbreaking discovery. And researchers are even looking ahead beyond the potential advances of this newest run of the Large Hadron Collider, as there are already plans in place for the LHC to be reinvented in 2029 as the High Luminosity Large Hadron Collider, which is projected to increase the number of detectable events by a factor of 10. Additionally, plans for a future circular collider are in the works, which will bypass the 13.6 trillion electrovolt speed of the LHC and reach mind-boggling speeds of up to 100 trillion electrovolts. Despite the futuristic and almost unbelievable capabilities of the current Large Hadron Collider, which is already pushing the limits of what was believed possible, the field of physics is persistent in its desire to unearth the smallest, most deeply hidden secrets surrounding the particles that make up the very fabric of our universe. Mysterious Alaskan radioactive particle. On a flight from Anchorage to Hawaii, scientist Dave Murphy was on a mission to discover what kinds of particles were in the atmosphere on behalf of the National Oceanic Atmospheric Administration, to figure out how air pollution was affecting our climate. Of all the thousands of particles he collected, he certainly wasn't expecting to find an enriched uranium particle. As soon as he analysed those samples after landing back on the ground, he knew that the uranium particle wasn't naturally occurring. It was the type that would be found in dangerous nuclear weapons and fuels, like the weapons that were dropped on Japan during World War II. How and where did this mystery particle come from? After further research, Murphy guessed that the particle must have originated from somewhere in Asia and was carried all the entire way over to Alaska by wind trajectories and particle dispersion. Yet, he couldn't distinctly point to any one country. Even so, he reassured everyone that the atmospheric uranium particle wouldn't need to raise any concerns or worries. In fact, it was so tiny in size that it couldn't have been seen with a small optical microscope. If Murphy took another flight again, he stated that it was rare enough that he most likely would never see another one again. In the meantime, it is a mystery that's waiting to be solved and already has some revolving theories. Some experts believe it's from North Korea and their nuclear tests, but there's no solid proof yet. The particle could also have been from past nuclear accidents like Chernobyl or Fukushima, but it's unlikely to have been floating in the air for so long ever since. In the end, it's possibly just a small source of uranium that scientists have yet to truly understand. In the hopes of one day capturing its true origin, Murphy had published a paper about his findings. His research may potentially change how we view our atmosphere as we know it.